We are using the technology since 1996, but with different partners. But the first machine we have bought in 2006, and since 12 years we are using our own machines in the prototype department in SEAT.
Automotive industry has been using additive manufacturing for a while now, more for rapid prototyping and tooling. So it's not additive manufacturing as such. I think now in the next years we are going to start seeing some real parts produced by additive manufacturing in cars.
In my case, in the company that I work in, KTM Technologies, they are working since 2018 in additive manufacturing, and we are kind of a growing, emerging group looking forward to include this technology into serial production, into real applications for the motorbiking sector.
Our company, CRP Technology, is in the automotive industry since 1970, specifically with additive manufacturing. We're working since 1996, where we started on wind tunnel applications for automotive industry.
Nosotros hoy en día estamos utilizándolo para fabricar pequeños útiles y herramientas. Probablemente en un futuro muy próximo utilizaremos también para hacer otro tipo de útiles relacionados con el montaje de vehículos.
So currently there are many applications pretty useful in terms of rapid tooling for fixtures or jigs that companies really need the faster way. And that's for sure one of the main topics in many organizations. Regarding the main applications, I will summarize that these fixtures and jigs. And concerning the current needs, I will focus on parts for electric devices into automotive sector, for example, and battery stacking, for example, as in electric motorbikes or electric vehicles.
One of the main benefits is the flexibility of the technology. Also is the speed. Okay, we have no wait to have the first prototype, the first part is very fast. We have, when we make a decision to make a change in a part, we can have in 2 days the new design. This is the main benefit, the flexibility and the speed of the technology.
In motorsport, the benefits are parts that can be much lighter, much compact, and with a much higher efficiency. From High-Tech Technologies, we design and manufacture heat exchangers for applications such as intercoolers and radiators. And the benefit of producing these parts by additive manufacturing compared to a conventional manufacturing method is that you can have a much lighter part and much more efficient. And that's a big benefit in motorsport.
Hay dos principales. Uno es el coste, mucho más barato que otras técnicas de fabricación tradicionales, y otra es la reactividad, el poder tener algo que necesitas una solución en pocas horas con respecto a hace pocos años que teníamos que hacer lo mismo en la calle, con unos plazos de entrega mucho más largos, un precio totalmente distinto, etc.
We use all the technologies in SEAT. Part of them we have in our own facilities, machines for FDM, SLS, SLA, but also we are still using the technologies with the partners that we don't own, but we use with service bureaus or with other companies. And also with the group, with the Volkswagen Group, we also use the technologies available in the different companies of the group.
We only use SLS technology. Wind form materials can be only printed in SLS technology, and we are actually starting to take a look into other technologies, newer technologies.
Currently, KTM Technologies is benchmarking different technologies. We have in-house an SLS machine We use this system and this technology because we think it's one of the most economic ways to get final details of the prototypes, but also we are going forward into check all the technologies, and we are doing in the current projects for SLA, for clip technologies.
Bueno, la innovación más interesante es eso, que nos permite utilizar plásticos que hasta ahora no utilizábamos con características mecánicas diferentes a las que estábamos utilizando, con lo cual nos permite hacer cosas que antes no hacíamos. Básicamente es eso, nos da una flexibilidad que antes no teníamos.
We use state-of-the-art software tools like topology optimization, CFD optimization, and so on. So we are starting now to understand that understanding the process is very important to predict the deformation and the dimensional stability of our parts. So we are starting to use more and more process simulation.
In 10 years, I am sure that technology will be included in the serial cars. We are not so far away to achieve this goal.
So I think in 10 years the use of additive manufacturing is going to be pretty well established for some cases like fixtures and jigs. They will be pretty common, but to have stocks and warehouse with not that really significant parts, and I think it's going to be pretty established in 10 years.
Bueno, me imagino que en 10 años seremos capaces de ya imprimir en metal de una forma más sencilla que a día de hoy, ¿no? Que te implica pues, un tipo de máquina compleja, que tiene que estar en una atmósfera específica, en fin, me imagino que esto conseguiremos también abaratarlo y simplificarlo para poder utilizarlo en el día a día de la fabricación de vehículos.
Well, it's going to be a disruptive technology, that's for sure. I think we cannot even imagine how different it's going to be the processes we use in automotive in 10 years thanks to additive manufacturing.